This presentation covers an overview of Six Sigma. It is brought to you by Team 5 of Penn State's Information Science and Technology Program's IT Project Management course. Businesses exist to grow shareholder value. Shareholder value grows when businesses sell products, and more products sell when they are good quality and free of defects. If a business's products are poor, customers and consumers will stop patronizing the business. To produce products, businesses follow formal business processes so that their methods are repeatable and able to be improved. Improving these processes leads to lower costs, better products, and better profits, and more shareholder value. There are many methods, both defined and undefined, to control product quality and refine business processes. Six Sigma was developed by Motorola in 1981. It uses quality management methods and a supporting cast of subject matter experts in each method. Six Sigma creates quantifiable quality targets so that the Six Sigma team can track their quality level. Six Sigma's ultimate goal is defect-free products. The target metric is 3.4 defects per million units, or a 99.99966% defect-free product, which is 6 standard deviations, or sigmas, from the mean. What is quality? Philip Crosby, a noted IT analyst and consultant, said that quality is 0 defects, with no room for error, planned or unplanned. Quality is determined by a customer's needs. A quality product meets customers' needs. In the technology world, this is important when one thinks of electronics in airplanes, cars, and medical devices. Six Sigma is focused on quality because preventing problems is cheaper and easier than correcting mistakes. Product defects can be extremely costly. Toyota's acceleration defect is projected to cost the company up to $2 billion. DMAIC methodology is one of the main Six Sigma process improvement methods. It is focused on existing business processes. DMAIC stands for Define, Measure, Analyze, Improve, and Control. The first step in the process is to define the problem or opportunity, project goals, and customer requirements. A project manager can use the project charter, requirements planning, process maps, or direct input from the customer to define the process. The next step is to measure key aspects of the current process. This measurement is defined in terms of defects per opportunity. The third step analyzes the measured data to investigate and verify cause and effect relationships. Six Sigma users can apply a variety of methods to analyze the data, including root cause analysis and a fishbone diagram. The fishbone diagram uses the 5 whys question-asking methodology. It is believed that 5 iterations of asking why are generally sufficient to reach the root cause of the problem. Asking these questions can avoid assumptions and force investigators to look deeper into a problem. The fourth DMAIC step improves and optimizes the current processes. Pilot processes may be created to test proposed improvements. These improvements will be measured and analyzed for their effectiveness. The final phase of the process controls for process deviation. Controlling for deviation can involve statistical analysis, business controls, and other tools. This step ensures that the improvements are continually followed. Six Sigma companies use a number of quality management tools within the DMAIC process. These include control charts, run charts, scatter diagrams, and Pareto charts. Control charts show whether or not the process is within a given set of guidelines. This chart shows a product with an upper specified limit of 12.1 inches and a lower specified limit of 11.9 inches, and all of the items produced over a given interval of time. Six Sigma teams can look at this chart and determine whether any products were out of spec, and on average how far from the mean the products deviated. A run chart shows the number of defects over a given period of time. If the number of defects is increasing, then there's a process problem. Scatter diagrams plot many data points against 2 values. One can also use a line of best fit to determine the overall trend of the data points. On this chart, one can see that user satisfaction increases as the age of respondents decrease. Pareto charts show individual values and cumulative totals on 3 axes of data. On this chart, the individual values representing login problems, system lockups, and so forth are shown on the left x-axis. The cumulative total of all problems is represented on the right x-axis. Six Sigma draws its name from the Greek letter sigma. which represents standard deviation from the mean in statistics. This graph shows a normal distribution and 3 standard deviations from the mean. 3 standard deviations from the mean in product defects would still mean a rate of 6.7% defects. 6 standard deviations, or sigmas, would mean a defect rate of 0.00034%.
The 6 Sigmas themselves.
They're dudes?
Each of them embodies a pillar of the 6 Sigma business philosophy. Teamwork, insight, brutality, male enhancement, handshakefulness, and play hard. Wish me luck.
There are a number of implementation roles in the Six Sigma universe.
Hi, I'm Liz.
I'm Prashant. This is Joan. We're M7s. What level are you?
Oh no, I'm just here with my friend. Or I was.
So you're like a G or an H?
No, I'm not part of this. I'm not any letter.
J?
There are actually 7 distinct roles. Executive leadership, which comprises the company's top management and empowers the other Six Sigma team members. Champions are next. They're responsible for Six Sigma across the entire organization in a strategic sense. Master Black Belts are Six Sigma's coaches and evangelists. They focus on spreading their in-depth knowledge of the Six Sigma process to other members of the company. Regular Black Belts focus on implementing Six Sigma directly and using green, yellow, and white belts to help implement the steps of the DMAG process. Six Sigma is not limited to Motorola. There are a wide variety of companies that use the Six Sigma process to limit process defects, including Amazon.com, Dell, GE, Lockheed Martin, Merrill Lynch and Bank of America, the U.S. military, and Xerox. Six Sigma is not limited to technology companies or manufacturers. It can be used to improve processes in virtually any business. Six Sigma does have its critics. Some believe that the belt system is self-fulfilling and serves little purpose aside from creating an army of expensive consultants. Others believe that Six Sigma may stifle creativity. Some studies have shown that Six Sigma implementers only gain minor process improvements at the expense of rejecting radical new process ideas in favor of safe, incremental, and measurable changes.
What is this?
It's lunch. Lego utilization for negating crisis hierarchies.
It's a competitive team-building exercise where one person directs his teammates in the construction of a Lego model that only he can see.
Lemon, why don't you join Team Donaghy? We'll win this thing and then we'll go to class.
I don't want to go to a class.
No, Lemon, class is an acronym for consuming lunch and simple socializing.
Now that just seems intentionally confusing.
Finally, Six Sigma has a number of competitors. TQM, or Total Quality Management, is an older process improvement framework with less focus on statistical analysis and measurable items, yet still aims to decrease defect rates and increase customer satisfaction. Lean manufacturing, designed by Toyota Motors, aims to maximize customer satisfaction by eliminating wasted resources that do not improve the customer experience. The theory of constraints states that there is always at least one constraint that limits the process, similar to a critical path, and that if a company continually identifies and improves those constraints, then their process will improve naturally as well. Six Sigma improves business processes. It exists to save the company money by reducing defects and increasing customer and client satisfaction. Six Sigma uses a number of tools, including the DMAG process, to continually define, measure, and improve processes. Six Sigma, however, is not perfect, but when implemented properly, it can be a major advantage to a firm.